We're now going to look at a type of function called a piecewise defined function. A piecewise defined function is a function that is defined differently on different parts of its domain. For example, we have the piecewise defined function, which has three rules. The first rule is that we're going to use negative x plus 1 if our x value is between negative 1 and 1. We're going to use a value of 2 if our x value is 1. And we're going to use the graph of x squared if our x value is greater than 1. So the first thing that we want to do here is graph this piecewise defined function. So we're going to use some of the knowledge that we have from our library of functions that we looked at in the last presentation. So I'm actually going to begin with the third function. So I recognize that third function as the square function, and I know that that is going to graph a parabola. So I'm going to come to my graph and I'm going to sketch out a parabola. And remember, we know that that parabola, as for x squared, just sits with the vertex at 0, 0. Now, the other thing that I want to do is I want to realize that I'm only going to use part of this graph. So the only time I want to use this graph that I just drew is for x values that are bigger than 1. So here's the x value equal to 1. So I'll kind of draw myself a line right there. And I only want this graph for x values that are larger than that. So I know that values that are larger than 1 are going to go to the right. All right, so what I'm going to do is I'm going to come to my graph and I'm going to erase everything to the left of that purple line. Okay, and then I'm also going to erase the purple line. We don't really need that there. And what I'm left with is the graph for x squared if the x value is bigger than 1. Okay, now the other thing that I'm going to do here is I'm going to look at what happens at that 1 point. All right, so if x is equal to 1, then when I plug it into my function, I also get a 1. And so that means that we have as a point 1, 1. But now keep in mind that that point is not actually included on the graph. So what I'm going to do is I'm going to put an open circle right here on the 1. Because that graph is not, that point is not part of that particular function. All right, so now I'm going to move and I'm going to look at the first one. All right, so I've got the graph of negative x plus 1 that I need to work on. So I'm going to do a quick table of values so that I know where that graph is. I'm just going to plug in a couple of values. So if I plugged in, say, 0 into my function, I would have 0 plus 1. That's going to be a positive 1. And then what if I plug in a 1? If I plug in a 1 for my function and for the x, negative 1 plus positive 1 is going to be 0. So that just gives me a couple of points that I can actually plot on the graph and see where this line is going to be. All right, so 0, 1 is going to be here, and 1, 0 is going to be here. And so I'm going to draw a line through those 2 points. Now again, I only use this particular graph in certain places. So I'm only going to use it between -1, which is here, and +1, which is here. So everything else is going to need to be erased. So I'm going to come in and I'm going to erase outside of those purple lines. And then I'm actually going to erase the purple lines as well. All right, so let's look at the endpoints. So at -1, we have a less than or equal to, so that's going to cause me to have a solid dot on that -1. And on the +1, we're going to have an open circle because it's not included as part of the graph. And then finally, the last one that we have to do is the constant function, f of x is equal to 2, which we know f of x is equal to 2 does a horizontal line up at 2, but note that we only want this when x is equal to 1. So actually this is one single point. The x value is 1, the y value is 2, and so we'll go and we'll place a point at that point on the graph. But not there. Hold on. So I'm going to put that point at 1, 2, and we'll have a point right there. Okay, so now we have our graph drawn. We're going to go ahead and answer the questions underneath. All right, so the first question says to find f of 0. So we need to look at where the x value is 0 on the graph. All right, so if the x is 0, we can see it looks like the y is going to be 1. So I'm going to go ahead and write that down. The other way that I can do this is I can come back up to my 3 equations. I can find the one that includes the 0, which would be this one. This is the one we're using for x values between -1 and 1. And we could plug it in at that point. So if I'm plugging a 0 in for the x in that equation, I can see that I do get 1. All right, now we'll do f of 1. So if x is equal to 1, we know that the y value is equal to 2. And so there's not much for me to calculate there. And then finally we want to do f of 2. That would be an x value bigger than 1. So if I plug a 2 into that equation, I'm going to get 4. And so for each of these x values, you simply want to look either at the graph or look at the appropriate equation and calculate. The next question is asking me for the domain. So my domain, by looking at my graph, the leftmost point on the graph is at -1. It is included as a point, so I'm going to put a bracket. And the rightmost point on the graph is going to be reflected in this arrow, and that arrow tells me that it continues on to infinity. So we'll say that our domain runs from -1 to positive infinity. Remember, your infinities always get parentheses. And finally, the range. The range, we're going to go from the lowest point to the highest point on the graph. All right, we can see that the lowest point on the graph is at 0. 0 is not included because it has an open circle. All right, and I'm looking right here. That's the lowest point on the graph. And the highest point on the graph, again, goes to positive infinity. So for a piecewise defined function, you would want to be able to sketch a graph of that function and also answer some questions regarding either the graph or the function itself.